Hello everybody, I'm Nick, and in this video I'm going to show you 9 rules that can help you write cleaner code. This rule set is called Object Calisthenics, and it was defined by Jeff Bay back in the day in the Thoughtworks Anthology book. And it talks of 9 rules which I prefer to define more as guidelines, because defining them as rules sounds harsh and absolute. So I'm gonna say guidelines to help you write cleaner code, and it's building upon principles like YAGNI, solid, kiss, dry, these types of acronyms that we all use to write cleaner code. Now, clean code is a very subjective thing, and what is clean for me might not be clean for you, but we're gonna try to explain why they're considered like this and whether we should even use them, because yeah, they're 9, but I don't actually use all 9 of them. And I've actually adapted some of them because I don't agree with the original definition. So I'm going to talk you through the ones I use, the ones I don't use, and the ones I have adapted to my own liking. Now, the reason why I'm making this video is because I made a refactoring test video before this, and many people ask how am I going about refactoring code and how I identify those patterns. So Object Calisthenics is one of those things I have in mind, and I just naturally do nowadays. If you like this type of videos and you want to see more, make sure you subscribe and ring the notification bell so you don't miss any new episodes. So let's go straight into the code. And what I have here is 9 projects, 1 project per Object Calisthenics guideline. The first one is called only 1 level of indentation per method. So what we have here is some sort of cache that we call the build cache method, and then it's building some caching around that through the through some objects. Let's see what the method looks like internally. So what we have here is a nested for each loop. We're processing a data table, so we're going rows first, columns second, and then we are checking if there's an error. If there is no error, then we continue and we process the columns, and we're matching on the columns and rows, and we're adding items. Now, the rule says that this, where my cursor is right now, is indentation level 0. And you can go as deep as here when it comes to nesting. You cannot go deeper. So this is kind of violating that rule because you're nesting in 2 levels deep. Code that is deeply nested is actually hard to read. In this example, it's a very microscopic example and you might not actually see it. You might be like, I can see all the code, but I'm sure that you have code that has deep nesting that is very hard to read and work with. The solution to that is using method extracting. So you can simply use the extract method functionality of your IDE. And in this scenario, what are we doing? We're parsing the columns of the data table. So I can just say parse columns. The reason why I'm using generic names as parse columns and not something more specific is because the example is generic. You might initially be, let's say, iterating over clothes like hoodies, and then you might want to have a color iteration as well. So you're iterating for every color of every item in a deep nesting pattern. But for now, I'm just going to extract it using a very generic name. And the other thing I want to extract is the outer for each loop, which can also be extracted to a parse rows or even parse items, depending on how you gonna name this, depending on your context. And now this continue statement kind of violates that rule still, but we are not going to remove it because continue doesn't really have much logic in it. It's easy to read and it's better to leave it like this. And also I intentionally have the curly braces here and I don't have them removed because I like to have the curly braces defined. Code that defines the context is less prone to errors. And now the main code, which is this, is way easier to read. I just need to know that I'm parsing the rows, and then if I need to check them, I just go to the method and I see what's happening in that method, and then if I need to go deeper, I go down. You might say that now the code is less readable because I have to scroll and find every method that this original method is using. I disagree because you don't read a class usually, you read a method, especially when you're working on it. So it makes more sense to separate them with meaningful names. Not only it makes it more manageable to work with, but you might get other side effect benefits like better stack traces when you're debugging your code or when something is happening that is wrong, or you might be able to read these smaller methods easier. And this is one of the things I am personally using. So if you go to the refactoring test code that I did in the previous video, there is no more than one level of indentation in terms of nesting per method. So this, I have seen it working, I know it works, and I've personally used it, and I do recommend you using it. Let's go to the next one. And the next one is called don't use the else keyword. Now, I already have a video talking about this very thing, and I actually go on and on with more examples. So for that reason, I'm just going to tell you to click on the top right corner of your screen right now if you want to check that and then continue this video, because I cannot do it justice in a 20-minute video. It did actually require a bigger video, which I already have out. So I'm going to skip over that. But the general statement is don't use an else keyword. It might sound very absolute, but please check that video because I do explain why it makes sense to do it. Now the next one is called wrap all primitives and strings. And the differentiation there is because in some languages, strings are not primitives. This is another video. This is another topic that I actually do have a video out, and it's the video I have for primitive obsession, which is another thing you can click on the top right corner of your screen right now to check. So for that reason, I won't really stand on it in this video because I do it justice in a different video. I highly recommend you go check that out instead. Luckily, rule 8 actually builds on top of that idea of the rule 3. So we're going to talk more about it in this video as well. But just to keep this video more to the point and focused, you can check that rule in that separate video. So let's go to the fourth one, which is first class collections. What I have here is a client service. And this client service has a bunch of things. It has a logger, it creates and it gets a client by ID. Obviously it's all fake, it's all in memory. And it also has a dictionary. And this dictionary has a GUID as the key and a client as the object. Now, first class collections says that if you have a class that has more fields than just this single collection of items, whether that's a list or a dictionary, then that thing, that collection, that dictionary in our case, has some domain logic behind it, and it should be encapsulated, it should be in its own class. And the reason for that is, in my case, it represents my clients. So should the client service directly be able to mutate and get anything it wants from that dictionary? Well, maybe not. Maybe we should replace that with its own collection called client dictionary in our case. And now, if I go to the client dictionary, I am composing my own client dictionary using an internal dictionary, and I'm exposing to the user only the things that I want to allow to this collection to happen. So I want create, I want update, I want get by ID, and I want delete by ID. I want these very specific things. Could the service do it itself? Yes, sure it could. But by wrapping the collection in its own class, I'm giving it a more well-defined structure and reason in my domain. You know, it's my client dictionary. It's a very specific thing. So now my code would change, and instead of just doing add on the dictionary, I would do clients.create. And what does create need? Well, actually, I forgot what create needs. The client. So how the GUID will be used internally to create the client, I don't care. I just give it a client and creates it for me. Same goes here with the get by ID. Should I handle any default logic here? Absolutely not. Let's do that in the collection that is responsible for it. So the collection now became a first-class citizen in my class by having its own thing to represent, its own class. This is one of the things that to me are more situational, so I don't use it all the time, but when I'm working with domain-specific things, I am actually using it. It's something that you could actually just skip over, but I do see a big benefit in using it when you need it. The next one is called one.per_line. So let's take a look at this main class here. As you can see, I'm using the configuration of a .NET project, and I'm trying to get a specific item from the configuration structure. So I'm going DynamoDB, region details, and region name. And this will be nested objects in memory of the configuration. Now, the rule says 1 dot per line. As you can see, I have 2 dots here. This is one of the two things that this 1 dot per line rule means. So instead of doing this code is very hard to debug, kind of hard to read, but not terribly hard to read, but it's very hard to debug, because if I just want to see what the value of this is, I have to open the debugger window and try to compute it on the spot during runtime. So it's very hard to see what went wrong, especially if something goes wrong in this line as well. Like, what went wrong? You don't know. So something like this would actually be written DynamoDB section, and then you would extract the DynamoDB section here, then region section, and you would have DynamoDB section dot get section here, and in the end you would have the actual region name, which I can actually do this region section. Now my code is easier to read and also easier to work with. This might make more sense in a more domain entity area. So let's say that I have a pet. So let's say new pet here. And I want to update the postcode of the pet because the pet is registered in a specific house. So I'm going to go pet.set postcode E14LY, I don't know, something random. And this might look fine to you. But let's take a look at what's going on in the set postcode method. The set postcode method is going to the owner, which is an object in the pet class. It's going to the home address, and then it's going to the postcode. Now, should the pet class know about the home address of the owner? Not really. The person, because the address, the postcode, is driven by the person, not by the pet. So this would look more like set postcode here. And yes, the person knows about their home address, so they're able to mutate that. And then if you want to do it in the pet level, I mean, just use the owner dot set postcode and set the postcode here. And now we again eliminated this 1 dot per line thing. However, this rule does not apply when you have a Fluent API or a query builder. So if we had something like this, I know that there's a config builder actually. Let's say a new configuration builder. Yeah. So in that type of scenario, you have the chained things like add, and you can have as many as you want. In that scenario, it's fine to use it. What I like to do personally is a new line on dots, because it makes it easier to follow in terms of what you're doing. You just need to know that this 1 dot per line doesn't really apply when you have a Fluent API or link in .NET's scenario. You don't need really to think about it if you do that. Basically, it is to satisfy the law of Demeter, which says that you should only talk to your immediate friends, you should not talk to strangers. And this is the reason why that specific rule exists. This is another thing that I tend to use a lot, but sometimes when I'm doing link and more complicated things, I might skip over, but I am actually trying to use this as well. Next rule is called don't abbreviate, and this one is one of my personal favorites because I see it all the time. It makes sense to abbreviate for some other languages. I know in Go or C++, but in languages like Java, Kotlin, C#, Python, JavaScript, whatever, you don't need to abbreviate. Don't abbreviate. And what does abbreviation mean, right? Let's go to this YouTube channel object here. Here you have two things. You have a decimal called CPM. Now, what does CPM mean to you, right? Well, it doesn't actually mean anything. Or it might, but probably doesn't. Now, CPM actually defines something called cost per mil, which is how much revenue you make per 1,000 views through ads. So don't type CPM, cost per mil. It makes it easier for you to read what it is, potentially Google it as well, and also communicate it to business to say, okay, can you explain to me what cost per mil is? Give long descriptive names to your properties, fields, methods. However, this value, which does have a long descriptive name is also wrong, because I know the context, right? I am in a YouTube channel class, but this still has a YouTube channel ID in the name. I don't need that. Just remove it. If you name something ID in a class called YouTube channel, I know that you're talking about the YouTube channel ID. You don't need to tell me. You can see this in this user service even more, where you have a user service and then the methods are called add user, edit user, delete user. I don't need to have the user here. Why do you have it, right? If I just tell you add, edit, delete, what do you think I'm editing? A crocodile? No, it's the user. Don't have it here. So long descriptive names, but when you're context aware, do not bloat your naming with things that can be interpreted by just looking at the class name. This is one of my favorite rules. I use it all the time. It just makes so much sense, especially in C#, to have long descriptive names, because it makes it so easy to work with and onboard people that might not know the domain so well. So yes, absolutely use that. The 7th rule is called keep all entities small. Now, this rule is a bit... okay, I'm going to tell you what the original rule says. So the original rule defines that you should not have a class with more than 50 lines of code, and no package. By package in this context we mean folder or namespace. In Java it would be package, with over 10 files. I mean, I get that your justification writing this would be that more than 50 lines violate single responsibility principle, but come on, 50 lines? Do you know how much is 50 lines? This file is 30 lines. It's not something I follow. Other people might tell you the following. So keep classes under 100 to 150 lines of code, keep methods under 10 lines of code, and then classes under 5 properties and classes under 5 methods. This is more something I can get behind, but again, it's not something I can just look you in the eye and tell you do this, you know, even as a guideline. What I'll tell you is just do whatever the hell you want, as long as you don't violate single responsibility principle. Because it's more important to not violate SRP than to follow an arbitrary rule around a number of lines, which can be inflated in so many ways, you know, especially with method extracting, which is a good thing. But if you extract methods, then you might violate this rule, which is not really a violation, really, right? What I think in my mind when I'm working with code is that when my class reaches or goes close to 250 lines, then it probably does way too much and I need to refactor it. But I don't think that setting such a rule makes too much sense. So in my opinion, yes, I know what Jeff wrote this, but I cannot really get behind this. So it's up to you if you want to use it. For me, I choose to say that if I'm reaching 200, 250 lines, then I'm like, okay, hold up a minute, I might be going too far. But that's as much as I'm going to say for this specific rule. It's up to you to do whatever you want. Now, the 8th one is called no classes with more than 2 instance variables. What does that mean? Well, let's look at the player service. This player service has four instance variables: the logger, the metrics collector, account service, and game client. We just violated by 2 by doing that. But in my opinion, we need all of them. This is another one that I don't really agree. I get it, and it makes more sense if you go to models and you go to the player character, right? Where in the player character, imagine this is a game, you have the name. Actually, let me show you how this is being initialized. You have a name. If you play something like Call of Duty, you might know that your name is your username and then a tag. So this is what we're building here. And then you have a character, and the character has 2 properties here, the player name and the player ID. And the player ID has the value, the player name has the username and the tag. This is actually satisfying that rule. I find it easier to do such things in a more DDD scenario where you have value objects and you try to break things down to way smaller manageable pieces. This is another one that I feel like I get it, but realistically I probably won't be able to apply it. It's easier to apply in microservices, but I cannot, like if you're building something like a Blazor app, and you have a bigger component, you might not be able to use that, or a bigger application altogether. So I get it, but I don't really think about it when I'm using it. I do, however, in my mind say, okay, we're exceeding 5. Is this class doing too much? I'm injecting way too many things here. But things like the logger and the metrics collector, I don't count in that 5 number, because those are things you want to improve your resiliency and your debugging experience. So yeah, maybe if you're injecting 5 things from 5 different services, then that class is doing way too much and you should reconsider it. But it's yes, but under some conditions. But that's another thing that I don't really get behind, unless it is very obvious that this class is violating single responsibility principle, which is what this is all about. The last one is called no getters, setters, or properties. That's another one that is vaguely absolute, and let's see what that means. Let's say we have 2 football teams. Actually, the majority of my audience is American. Let's say you have 2 soccer teams, Arsenal and Manchester, and you want these teams to play a game. So you have a home team and an away team, and Manchester scores a goal. How do you count that, right? You would go to game, and then you would go to the away team score, and then you would say value and plus to increase it. This would be a violation of this rule, and rightfully so. I totally agree with the rule in that context, in the domain entity context, because it's not the responsibility of whatever class I am in here to know how to score a goal, how to increase it. This value shouldn't have a setter, or the setter should be private and it shouldn't be exposed. And instead, if you want to score a goal, just have a score goal method. So score goal. And we're doing this because we want to satisfy the rule tell, don't ask. I don't want to leak my encapsulation outside to some service. I'd rather be the one who's responsible for this class deciding how this class will be mutated and exposed. And in that context, it does make sense to have the score goal method call here, because now the score object itself knows how to increment itself. It knows how to add a goal. It knows how to subtract one if you actually get a goal removed because of some reason. So really, this rule does make sense, but it makes more sense in the context of objects and entities in the domain level than something like a DTO or a contract from an API. That's another rule I do actually use, but very specifically to the domain level. So these 9 guidelines do make this thing called Object Calisthenics. And like I said throughout this video, I'm using some, I'm not using some, I've adapted some because I don't think that they all make sense in the way I'm writing code. Tell me which ones you're using or not using, because I'm very curious, and let me know what you think. That's all I had for you for today. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you can find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.